class. So today we're going to talk about Module 5, Part 2. So we're still looking at inferences from two samples. In Part 1, we looked at when they were independent, and now we're going to be looking at what happens when they are dependent. Okay, so inferential statistics involves forming conclusions about population parameters. Those population parameters could be your population proportion, which is your P. Okay, so population mean, mu, or population variance or standard deviation, so your sigma squared or sigma. The activities that we could perform on two samples are estimating the value of the population parameters, using confidence intervals, and testing claims made about the population parameters. Okay, so just a reminder, independent versus dependent samples. Independent samples, these are samples taken from two different populations where the selection process for one sample is independent of the selection process for the other sample. Dependent samples, these are samples taken from two populations where either one, the element samples is a member of both populations, or two, the element samples in the second population is selected because it is similar on all other characteristics or matched to the element selected from the first population. So some examples of independent versus dependent. So an example of an independent sample: testing a company's claim that its peanut butter contains less fat than produced by a competitor. A dependent sample would be testing the relative fuel efficiency of 10 trucks that run the same route twice, once with the current air filter installed and once with the new filter. So with independent samples, assuming, again, we don't know sigma, again, that's very rare that we actually know that population standard deviation. So again, you're going to use that T statistic. Remember with that T statistic here, when you're doing that null hypothesis, you're always saying U sub 1 is equal to U sub 2. Therefore, the difference of these, so U sub 1 minus mu sub 2, is always equal to 0. So this is always 0. So in a way, we just kind of don't worry about that. Okay? So again, it's just saying that right there. Okay? Recall with your degrees of freedom, when you're dealing with two samples, we're going to pick the smaller sample size and subtract 1. So testing, okay, what happens when we test dependent samples? So a little bit more goes into that. The hypothesis test for two dependent samples is a bit different because we need to use the difference from each matched pair to test the claim. So just some notation that you're gonna need to know. So D, that is the individual difference between the two values in a single matched pair. So you're just gonna take sample 1 minus sample 2, that's your difference. Mu sub D, this is your mean value of the differences D for the population of all matched pairs of data. D bar, the mean value of the differences D for the paired sample data. And remember, to get the mean value, we'll be using average in Excel. S sub D, that's our standard deviation of the differences D for the paired sample data. Okay, and then N, the number of pairs of sample data. So key word here, it's the number of pairs. Okay, so when testing your dependent samples, your null hypothesis, we're always saying that the difference is going to be 0. So if you think back to the independent, we were saying that they were equal. So with a dependent sample, we're saying their differences are going to be 0. For our alternative hypothesis, we will either say that it's going to be less than 0, which means that the difference between the means is less than 0, so it's negative. Thus, the first group has smaller mean values. Or we'll say mu sub D is greater than 0. The difference between the means is greater than 0, so positive. Thus, the first group has larger mean values. Okay, so when testing dependent samples, again, we're going to need that T statistic because, again, we usually don't ever know our population standard deviation. So here it's a little bit different than the independent. So you have that D bar, and remember that's the mean value of the differences for the paired sample data, minus my mu sub D, okay? And again, that's just the value of the differences. And remember, that is always 0, so it's almost like get rid of that. And then it's divided by my standard deviation divided by the square root of n. And remember, that standard deviation is S sub D. It's the standard deviation of the differences of our data. Okay, so we have 2 examples that we're going to look at. The steps are going to be very similar to what we did in Module 4, what we did in Module 5, Part 1. It's just going to be different with, we have to compute a little bit more, and our t-statistic is a little bit more different. Okay, so here we consider one aspect of how we treat women and men differently based on their ages. Dataset 14, which is your Oscar winner age, in Appendix B, lists ages of actresses when they won Oscars in the category of Best Actor. The ages are matched according to the year that the awards are presented. Table 9.2 includes a small random selection of the available data so that we can better illustrate the procedures of this selection. Use the sample data in Table 9.2 with a 0.05 significance level to test the claim that for the population of ages of Best Actresses and Best Actors, the differences have a mean less than 0. Okay, so one thing I'm going to notice here, so we are testing the claim for the population of ages of Best Actresses and Actors, the differences have a mean less than 0. So again, that means Best Actresses are generally younger than Best Actors. Okay, oops, there we go. So let's go over here. And again, I'm just gonna kind of do that same thing. So I have steps 1 through 3. That's where I write my null and my alternative hypothesis. So H sub 0. Again, with this one, with a dependent, I'm always saying my mu is 0. And my H sub 1, I'm saying my mu is less than 0. Okay. So now I have that. Step 4. I'm going to be looking at, okay, so what's my alpha? Okay, well, going back to the problem, I notice this is a significance of 0.05. Okay, so my alpha is 0.05. Okay, so now before I do my t-statistic, so remember with that t-statistic, there's a lot more involved with that. I'm just going to bring you back to that slide. So I need to find all of these things. So now we're going to head over to our Excel. Oops, and I forgot to open it. So give me 1 second to get this opened. Okay, so we're going to go over to example 4 with the dependent. So one thing I'm going to do is I'm going to have to find the mean of differences. Well, in order to do that, I first have to find the difference. So to find the difference, I just subtract. So the first group minus the second. And I'm just going to keep doing this. Again, I do know that this is actually given in that, but it's good practice because you'll have to do this on your deliverable. And this way you can double check your answers to make sure you get it correct. Oopsies. That was, if I'm looking there, that is 35. Okay. Equals this minus this. Okay. So here's all my differences, and now to get the mean, remember that's where you do the average. Okay, and then I'm just going to highlight this and bring, 0.9 is, there we go. Enter, so I get negative 10.2. Now I'm going to do the standard deviation, so that's just equal, okay? And my standard deviation, I want to find it of the differences. So let's type that in. So my standard deviation, remember you want to pick of the sample and of the differences. So I'm going to go ahead and hit, okay, so I might just, they want me to maybe highlight this. I'm going to start over with my equation. So sometimes it can be a little bit picky on my, so there we go, because I guess they want me to put in your, I think on my, when I did it on my laptop, I did not have to do all this. There we go. Close those parentheses. Okay, so we get our standard deviation, 14.653. Now I can go ahead and find my t-statistic. Okay, so remember my t-statistic, if you look over here, it's just this right here. Okay, so I'm going to go ahead and plug that in. So this is equal, okay. Again, we got to use that, so it's my mean. Technically, it's minus 0, okay, divided by, okay, now again, following this, so it's my standard deviation, and make sure we do the parentheses, divided by, okay, the square root. Okay, of my sample size, well in this case there's 1, 2, 3, 4, 5 pairs. Okay, and then hit enter. So I get negative 1.557. And we could have done our, and here if you want to put that in. And remember you can use, if you want to count, that's the counta. I'm going to count how many pairs there are. If you, there we go. There we go. So there's 5. We'll just enter this in here too. If you want your degrees of freedom, because remember your degrees of freedom is just going to be n minus 1. So we have 4. Okay. So now we have our test statistic. Okay. So I'm just going to go ahead and record that on my sheet over here. Okay, so step 5. So my t-stat, we ended up getting negative 1.557. And again, if you want to write all that information, you can, but it is in our Excel, so we showed the work for that. So again, you don't have to do both, but I am going to show you both again. So I have my critical value and my p-value. Okay, well, remember this is less than, so this is, we're using that left tail. Okay, so, so here's my critical value. So again, with my critical value, I go over here, equals my t inverse, okay? And then it's my alpha, which I forgot to put in, so we'll just type that in, 0.05. And then my degrees of freedom, which is 4. So go ahead and hit enter. So then we get negative 2.132. I'm going to just go ahead and record this. So negative 2.132. Now remember our next step here, so step 7. And then I'm going to put step 8 over here. So step 7, you compare your test statistic to your critical value. Well, if I'm looking here, my test statistic is greater than my critical value, which tells me we do not reject our null hypothesis. So again, I'm going to do this p-value method just to determine, okay, does it match? Okay, so let's go ahead and calculate this p-value. Don't know why, there we go. Okay, so again, for that p-value, it's left-tailed, so equals, okay, so I have my t dot distribution, and then I have my t-value, my test statistic, my degrees of freedom, and then again, that is always true. Hit enter, so I get 0.097, we can say. So 0.097, and again, what we're wanting to do here, we compare our p-value to our alpha. Okay, well, I notice here my p-value is greater than my alpha, which tells me that hopefully you already know, we do not reject our H sub O. Okay, so then we just need to go over to step 8. And remember with step 8, so since we are not rejecting, we started out, there is not sufficient evidence that, and then I'm just gonna, that the population of ages of best actresses and best actresses have a difference of a mean of less than 0. Okay, so again, I'm just restating what we tested. And I'll let you guys fill that in. So again, it's just rewriting what I have highlighted there. Okay, so hopefully this first example went well. So we just have one more example to do. So again, I would recommend doing this one on your own and then coming back and checking to see how you did. Welcome back. Okay, so let's look at this last one. A popular theory is that presidential candidates have an advantage if they are taller than their main opponent. Interesting. So listed are heights in centimeters of presidents along with the heights of their main opponents. Use the sample data with a 0.05 significance level to test the claim that for the population of heights of presidents and their main opponents, the differences have a mean greater than 0. Okay, so let's go ahead and start. So again, that kind of step 1 through 3. Again, it's dependent, so is equal to 0. And my H sub 1, okay, and my mu sub D. And you know what? So this case is going to be greater than 0. And just a little side note for these ones up here, I did forget the D. So make sure that you write that with it. That was my fault. Okay. Okay, and then just so we know, this is, like we said, that's equal to 0. Okay, so step 4. Our alpha, well, we want a significance level of 0.05. And now we need to go to step 5. So again, there's no mention of our population standard deviation. So what is our test statistic? So let's go to Excel. And we're going to go over to example 5. Okay, so here we have for example 5. Now remember, in order to do the T, we actually need we need our differences, we need the mean of differences, and we need the standard deviation of those differences. So let's go over here. So remember to get your difference. That's equal to, oops, the first one minus the next, enter. Okay, I'm just going to keep going. Oops. There we go. And I did that again. I don't know why for that last one it likes to do that. So that's 173. Okay, let's go over here, equals. There we go. Okay, so now let's go ahead and compute our mean. So again, that is the average. Okay, and then I'm just gonna have the differences. Okay, and mine just does it a little bit differently, so I just have to make sure I erase that other stuff. Okay, so I get 3.667. Now I need to go ahead and do the standard deviation. So my standard deviation of the sample. Okay, again, here we go. Okay, so I get 6.89 there. So now I'm going to go ahead. Let's go ahead and do this here. And so I'm going to go ahead and count how many pairs we have. There we go. And my degrees of freedom, again, that's -1. Okay, oh, and I have my alpha in. Okay, perfect. So now let's go ahead and compute our test statistic. So I have equals, I'm gonna use this, so d bar -0, close the parentheses, divided by parenthesis. Okay, so my standard deviation divided by the square root. Okay, of n, and close those parentheses, hit enter. Okay, so now I get 1.3034 if I were to round. Let's go ahead and compute our critical region then. So remember, this is right-tailed because it's greater than, so it's going to be a little bit different. So remember with that, we haven't seen one of those in a little bit. So you start off with your t inverse just like normal. Now your probability, here's where it's a little bit, remember that's 1 minus alpha. Whoops. There. Okay, 1 minus L. Okay. I am just typing it in because I think in this case, I don't know why it's being so weird. Okay, comma, and then my degrees of freedom, which is 5. Whoop. Okay, hit enter, there we go. So my critical region, I get 2.012, and just since we're here on our p-value, I'm going to compute that as well. So remember, it is a right, so we have to do 1 minus, and that's my t distribution, okay? And then I have my t-value, and then you have your degrees of freedom, and then it is always true. Go ahead and hit enter. Okay, so I get 0.12458. So let's go ahead and move these values over. So our test statistic was 1.304. Step 6, I have my critical value and my p-value. So again, remember we got about approximately 2.02 here and 0.13 here. I think it was 1.2. Ignore that for a second. Okay, so here again is where we're comparing. So with my test statistic, I'm noticing my test statistic is less than my critical value. So when that happens, again, you want to make sure you're looking at the right-tailed. We do not reject. And let's see if it matches. My p-value is greater than my alpha. Okay, so again, we do not reject. Okay, and then, so step 8, no, step 7. My pen's kind of dying, so again, I would say that there is not sufficient evidence that, and then the heights of presidents and their main opponents, the differences have a mean greater than 0. Okay, so if you have any questions, please feel free to message me or join me for a live session. I'll be glad to help. Have a wonderful